So people who know me probably know I've got a habit of demoing things that are in progress and not ready for other people to play with. And why not just keep with the same habit? Sharing. All right, so for many years I've played with the idea of wanting to have a bit more debuggability in MicroPython, in particular in code debugging, stepping through, like a GCC debugging or a Python debugging. And I've had a few efforts at this in the past. Probably a few years ago, I had a PDB demo, which is all just completely command line debugging, and that was cool, but not very helpful. But recently, I've been using a lot of Claude AI, and it's helping me do things that used to be way too hard. So, took a run at this, and got a quick little demo of what I threw together with Claude's help to do some Python debugging in VSCode. So what we've got over in the terminal here, I'm just going to start the Unix port of MicroPython running this test VSCode file, which is in the other pane. It's going to start up. See, it's debug.py is listening. For reference, Python debugging in VSCode is run behind the scenes by a package called debug.py, written by Microsoft, that orchestrates all Python debugging. So what I've got here is a minimal re-implementation of that for MicroPython. But now that Unix MicroPython is running, I can attach to it in the VSCode debugger, and we're doing stuff, and we've popped up at a breakpoint that I'd set previously. If I need to, I could set another one there and run to a breakpoint. And over in the window, you can see it just printed out that statement above. And I can do the step, and we see it printing out things. And more that printing implementation, you can see, yes, it is actually MicroPython running. So that's all fairly anticlimactic, but it works.
That's very good.
And the thing that was weird about this is the first implementation I had of this was after 1 hour of coding from my phone. And I had an implementation ready to test. And it was back and forth, sort of splitting time with doing other real work over the course of about another 3 hours of testing. And I had a work implementation that I threw up on MicroPython lib as a little bit of a draft of a, hey, this is cool, but it's not ready for use, and let it sit there. And I got busy doing work and hadn't progressed it much, and all of a sudden Joss found it and ran with it and fixed a few of those issues that, like over here, the locals don't, well, they didn't have names and things. So without further ado, I might hand over to Joss and let him talk about how much further he's been running with it.
Yeah, so let me find Zoom, see if I can share mine. So yeah, I think that was really cool, right? To see that happening. And for me, of course, working with a different company, how do I now share from my part? Oops. Should be that part. So for me, I threw this out. For me, right, the journey started a while ago. I was working, trying to figure out how to make the stop things work, right? And I've got a stubber working for that, and I used MicroPython to do that. And I had written my test, and I was stepping through the test, and then weird stuff happened, right? So these are some of the screenshots from the issue that I created, right? Because the darn Microsoft debugger was broken. Oh, guess what? I work for Microsoft, but still, right? So I threw this out, and one of the PMs reacted at that point in time and said, well, oh darn, we're actually using MicroPython, right? And we're just looking at the name of the process, right? And there's Python in that process. So we'll try and attach a debugger, and it fails. I said, well, okay. Well, we figured out how.
Just wondering, are you trying to share? Like, we can't see your screen share.
Oh,
coming up all just brown tessellated. tile. Well,
let me try and reshare something. The brown stuff is boring.
tile something from your company.
No, actually, I got an ultra wide screen, right? And then trying to share that, it will be completely. So this is something that came out of some Stack Exchange thing. Is this better?
Yep.
Okay. So, right, this guy reacted and said, okay, well, MicroPython is getting close, but it's not quite there, right? And you'll need to do a bunch of re-implementation. Well, back in the days, I used to do C, right? But honestly, today, not anymore, right? I'll try to limit myself to Python, right? So this was always something like, okay, something could happen, but there's no way that I'm gonna make that happen. And then indeed, Andrew came and he said, hey, I've got this thing. And I thought, well, if he can work this out, right? At least I know it's not impossible anymore. Right? And then I started running through that and figuring out how his demo worked. And that was a bit iffy, right? But because I need to have my test project, and I need to have MicroPython checked out on a certain branch. I need to have the libs checked out on a different branch, right? And then, of course, I tried to make some shortcuts that really didn't work. And then the locals didn't work, and saying, oh, we're so close, right? And then I started asking the AI, how does this local thing work in MicroPython, right? And can you try and fix it, right? But we figured out how to fix that. Well, we and some AIs, right? But taking a step back, right? What Andrew just showed is, okay, how does this work, right? Because now we've got MicroPython that is, well, somewhat like Python, right? But definitely not under the hoods. So how can this debugger still work with that? And that's because, well, you might have heard of the LSP, the language server protocol, right? Where editors have one language to talk to all different computer languages, right? But via an extension mechanism. So the guys at VSCode figured out something. We have an editor, and we want to hook in different debuggers. So let's figure out the USB plug for debuggers, right? And that's a debugger adapter protocol. And that's just passing JSON back and forth over TCP channel, right? And you can have different implementations. Yes, you can have multiple debuggers running in VS Code at the same time. No, it's not just VS Code. It's being adopted by lots of other parties because, well, guess what? If on the development tool side, you know how to talk to DAP, then suddenly you have something like 20 or 30 debuggers that you can hook in. Right, and for the debugger side, it's smart to write to DAP because, well, then you're not locked into one editor or one platform. Right, so normally these debug adapters are running as a separate executable, right, or a separate process, right, or a daemon somewhere. For Python, the implementation, right, for CPython, the implementation is actually, well, a Python module which runs in process, which talks to part in CPython, which is set trace. And right, so in this case, right, we actually have the generic debugger, right, which does the attachment, and that kind of assumes that there is a full-featured Python debug PI running. Well, in case that's not the case, right, and there's some links to how it works, right. So in a picture, right, that's kind of what Andrew started with building, right. So yeah, on the left-hand side you have VS Code. You need to have your debugger installed there. And then, well, what you just need to do is, well, deploy the software, right, to either, well, the Unix version. I've also got it running on hardware already, right? Okay, just on ESP32, right? But if we can make it there, we can make it to anything that has a network stack. Because yes, we do need a TCP connection between one and the other. Then we need to deploy the source, right? On the firmware level, you need to have set trace enabled. There's a couple of compiler flags for that in order to make it happen. And there are some feature flags that, well, bump up the capabilities and eat up memory, right? And performance at this point. Then you need to have this debug PI module installed, the MicroPython flavor version of that. And then, well, what Andrew just skipped over is, well, then what do? Well, well, the running application needs to start listening, right, on either on the general port, right, or on a specific port and interface. Then you probably want to set a breakpoint because after that, and then you say, okay, per thread you want to debug this, and currently this is limited to one thread, right? And Andrew knows his way around that, right? But the first time was, okay, so I need to run 4 different commands and even to get something started, right? And it's really cool, right? I was really flabbergasted how it worked, but I wanted to make it even simpler, right? And now I need to reshare my other screen. So something like this, right? So are you now seeing my VSCode window? Yep, okay. No visual indication whatsoever, right? So what I really wanted is that, well, so in this case, so what I've put together is a demo repo which has the different pieces already strung together, right? So that it's easier for to get started. Right, and yes, I spent some time on this, but and I wrecked the MicroPython builds already a couple of times, right? So that my features disappeared or the breakpoints didn't work anymore, and I had this stable platform to go back to. So the way it's laid out, I've got a couple of firmwares here in the firmware folder, right? So there's one with where just the local names have numbers, and my preferences is where we actually save the names, but that burns a little bit more performance and memory. There is a bunch of settings which I'll get to, right? But most importantly, right? So there is the big module, right? The debugger, right? The debug PI module, and I've got my sources, right? Of course, I've got some Microsoft typing in there as well, right? But that's completely optional. So what I now can do is that if I just have, well, if I just have any application, right, then I can just have something, right, where I have an application, or and I can just say, okay, I'll enter this application, go to the debug menu, and I spend some time to add some additional options, right? So the one that I use most is run it in Unix, run it as a module, right? And then I start a launcher, and then I launch whatever script is currently under the cursor, and I run the main module, right? So let's just put in a breakpoint here. Then I just press run, and then what it first does is let's go through this, right? So it starts MicroPython, it starts a debug PI script, right? Or a start debug PI script. That's kind of a launcher. That's normally what's run in the full C Python as part of the debug PI script. I think we might want to merge that later on. Currently, this is just me playing around and being lazy because I just want to press F5. And that works, right? I don't need, in this script, there is nothing special. There's a main method, right, and a breakpoint. All the other stuff actually, right, that loads the debugger actually lives somewhere else, right? So the part that I worked on was really mostly until now trying to get the performance a little bit under control. But I can do a step in as well, right? So I can step into a function, and here I have a function, and I've got, well, some generated code, right, in order to do fancy stuff. In the beginning, there was nothing that was actually showing the local variables, right? Because in the normal compiler for Microsoft, these are just whizzed away. We don't need the names anymore. We know that it's variable 25, and that's good enough for the runtime. But in debugging, that was kind of, well, unhelpful, because that's in 99.95% of the case the exact thing that I'm interested in. So same as Andrew, I work with an AI to say, okay, there must be something there, figure out something, make changes to the compiler, make changes to all the glue stuff that's happening. And I think there's now 1 or 2 additional opcodes that are generated in order to save this information. Right, so I'm not quite sure about compatibility yet. But what you can see here is that actually we get pretty decent responses, right? I've done some additional work, right? Anything with underscore is a special variable, right? So these are recognized. And I also want to do that for the more complex variables, right? Which are, well, dict, list, whatever. But that requires additional handling in the debugger. And I want to have some tests and stabilize it before, right? So currently what you see here is they are just JSON-fied, right? So if it's a long thing, well, you might be able to read it, right? I tried wrapper first, but the spec says JSON. So this works quite well, right? And then, right, so we can step through this, right? And one of the things that we always work, that I've always, well, I know by now is, right, there's this consting, right? So, and we say, well, that's just a compiler thingy. So can we set a breakpoint on that? Well, let's set 2 breakpoints just right. So let's go to the next part. This is actually not even code, right? This is not emitted as code. Yet if I use it, then, well, it works, right? So this is kind of, right, one of the little things that happens behind the scene, right? So if we so the current implementation also has some problems, right? Because I kind of reserve text space now to store 32 of those names, right? So if I make a change such as now, I just want to restart. So can we make that happen? Oh yeah, right. So we can just continue on stepping through, right? Like you would do with a grown-up debugger, right? And say, well, let's continue until here, right? If I, right, oh, right. If I grow the stack too much, right, save too many variables, right? Normally it would start mumbling up the names, right? Then it will go bad, right? So let's set this to false, right? So just to show currently there's limits to what can be done, right? There needs to be done, right? This is really running around with scissors without any problems. So this was nice, right? And we can go, right? And let's do, so this is kind of my Uber sample, right? So let's, right? So suppose that you have some code that you want to run, right? And it's not behaving as you want, right? So normally you would need to do a lot of printing, right? So currently it's just okay. Critical error, right? Cannot open the door is locked, right? So what we can just do is, right, go for search in the right place, right? Let's look in the source part, right? Oh, here we have a critical error. There's my breakpoint. Let's go back to, right? So this breakpoint is actually leaving in a different module, right? So what I can see here is if I go to the breakpoints that I have is, as part of starting up the debugger, we need to map the local addresses to the remote addresses, right? So if we're using the Unix version, that's all going to be the same, right? So, but in this case, I'm just setting breakpoints. When I get started, right? If I start it, then it should have stopped there. It doesn't. Why not? So, and this is where it always gets interesting, right? Are we debugging the debugger, right? And that's part that I haven't figured out yet, right? Let's see if it works better if I go, right? So let's just step into that other module, right? See if it works then. Now it hits the point, right? So what I now can do is I have my call stack here, right? So now I'm down here somewhere in a class, right? In some method, right? Where is it called from? Right, so here in the class, I've got nothing much. I've got my global variables that I can see, right? But what if I go one level up? I'm actually going through the building on fire drill, right? So, right, and I can go to main, right? So I can go to the different levels of the call stack, and look at what are the variables and the local variables at that point in time. And it took me, right, and this is really helpful, right? This is way more helpful than just a printf. So there's a couple of more stack frames that I've kind of hidden, right? And this is where the debug starting part, right? This is the stuff that you don't need to insert into every module or every script that you want to debug, right? But that's the kind of the framework in order to get started, right? Loading the debug PI, listening on something, and currently I'm just loading up a module by name and starting a function by name, right? Or starting a method by name. Right, and these things you probably don't want to see, so they're kind of hidden by nomination. So this is real. So this is okay, right? Well, more than okay, right? So this really helps me figure out stuff way quicker. But then we're still not running on hardware, are we? Or can we? So I also built the same version for ESP32. Matt, we need to talk. I can't pass too many variables to MP build. It drops the last one. Right?
Fix that.
Yeah, but I we'll figure that one out. I've built it manually, and I can only build it in for not for the SPRAM version as well, right? But this is good enough for a test, right? So we can just deploy that, and I've done that already, and I've got that hooked up and connected to WSL, right? Because currently I'm running into WSL, right? So thanks to Andy's nice tool, but it's connected. So if I now run it for ESP32, what it will actually do is I've built a separate start debug script for, well, let's say the hardware version, right? So and I do an MP remote run for this, so that you don't need necessarily to install it. And then it goes through the same thing, right? It says, okay, we'll start with script called or module called target and a method called main, and it will go through the same. And then I've got because I changed the source all the time, it actually starts uploading the sources as well. And I've done the debug PI, it copies it one time as well. So essentially, right, there's a bunch of additional things that then go into where it now is saying, okay, oh, I made a change, right? So there's a couple of changes to my local files. It uploads it to the ESP32. Then, right, then this takes too long. Well, it takes too long, so there's a bit of waiting until it says, okay, debug PI is listening, and then it starts the debugger. And we're right in the middle of the same thing, right? And just to check, right, if we look at the globals, right? Yes, the implementation is actually in ESP32. We're running on hardware, right? And we can do the same things, right? So I probably should do the Wi-Fi scan, right? Just to make sure that, well, you see that it's actually connected to Wi-Fi, right? So we'll save this, restart it. Right, then what's happening here on the right-hand side is for all these things that need to happen, I've defined tasks in VSCode, which is a way where we can say, oh, if I want to start a debugger, actually what you need to do first is run a couple of tasks, right? And you can glue this together, right? And it's complicated to set up, but once it's there, it works really nice, right? So, well, it's not complicated, it's fiddly, right? And that's why I put this together once, and it probably makes sense that if this is a little bit more mature, yet we actually make a MicroPython debug plugin for VS Code, so that people don't need to do all this configuration. They can just download it, install it, and go to the races. It's not connecting, so oh, it's probably because I need to kill this. It ain't perfect yet, right? So let's just kill all these tasks, do it one more time, and So it's trying to upload my last changes to the hardware. So let's step into the scanner, right, which is at this point in time just uploading the Wi-Fi scan, right? So let's skip through here. And here you already notice it's a bit sluggish, right? If I step in here, you'll notice it even. Oh, this is something that we run into every now and then, where Andrew and I have been working on. It tries actually to download the sources from the debugging, right? And in this case, we actually already have that here, right? But then we get a sorry cannot download source, right? But if we look in our source folder, right, it should be there. Right, here's the Wi-Fi scan, right? So why don't we just put in a breakpoint here, hope that it still needs to get to there, and let it rip. Yes, and then it's there, right? So there's a bit of a sync thing that we need to iron out, right? If I just let it rip without any further breakpoints, right, then normally if I would run this, it would just say, okay, well, it will start scanning and it will list all the points. Here you see slowness in action, right? So yes, it's great, but it's running about 100 times slower than it used to do without debugger attached currently, right? Which still might be that I'm developing still 50 times as fast, right, as I would do with a printf, right? So that's what I wanted to show in the code. Let me briefly reshare the other thing, because there's a few things that I want to share. So now you should be seeing the PowerPoint again, because there's some things that are really great. We can do stack inspections. Yes, I've not demoed it because it broke the day before yesterday, but I've been able to step through through compiled file MicroPython files as well. Not if you do -03, because then all the line number information is thrown out, and we might need to have a special build for MicroPython cross in order to make it happen, in order for it to emit the proper bytecode, but it kind of works. It's cross-platform. It works on Mac, it works on Unix, right? It works on Windows, because, well, actually, what you just saw, I'm running Windows, remote connecting to WSL, that's connecting back out to, right? So it's cross-platform. It should work on any network port, right? And I think Andy is working on tiny USB things where anything that has a USB stack can be networked, right? So you don't even need to have actual hardware. That is great. And oh, I didn't show that. Yes, you can have parallel debug sessions with multiple boards running in parallel. The ugly, well, the first one you just saw in action, right? Sometimes you get this funky little open thing. The complex variable inspection, it can be better. It needs work. Oh, I forgot to say, yes, you have the debug window. You can just do random inspections. Anything that evals works. Not everything that XX works. You can't set variables yet. You can do imports, but in a roundabout way. So there's stuff that needs to be added, right? And well, there's no network, no debug, right? Today. The ugly. The firmware is significantly larger. Yeah. The performance hit is, I've done some optimizations that already saved a bundle, but it's still hundreds of times slower, right? There's no security, right? And there's very little testing yet, right? No coverage testing, no functional testing. I know Andrew started on a bunch of those. I also in a parallel thing, right? Work to be done, right? So how do you get started? I put what I just shown is run out of that repo that you have here, right? So it's np debug pi. I just vendored the stuff, right? I copied the stuff. So if you make changes there, yes, you'll need to send a patch, but not from that PR. Well, if you improve stuff, send the PR for this repo, but it won't end up in, let's say, the MicroPython fork or the MicroPython lib fork. Right, so it's just copied over. I've got my way of doing the debug and task configuration in there. It might work for you. You might hate it. Then delete it and build it as you want it. I've put my flavor of the helper scripts in there, right, to make it a little bit more dry. And of course, I've put the MicroPython stops in there because then I can write MicroPython code without being distracted by, oh, this stuff doesn't do it. And I think there's lots more to be done, right? So, Andrew, thanks for getting started on this, right? It's great, right? I feel like we've matured, right? This is it really feels like we're unlocking something. Great to help there, even if it's for a little bit. And there's work to be done, right? So I think what we need to do is figure out, okay, where do we talk about this, right? Is that just on one of the PRs, or do we create something on Discord or what have we, right? So, but yeah, it's been fun. It's been fun.
Yeah, I do think a Discord channel definitely makes sense. Yeah, it's certainly just a proof of concept at this point, but it's a big step leap from sort of where we were only a month ago. So I'm pretty exciting, and yeah, I love to see what you've done with it. And you've got a lot further in your repo than I need to look at a bit more, because I tried to run it on my RP2040, and it won't. The VS Code side of it never properly connects. Like when you hit connected, get the listen progresses, but the board keeps running, it doesn't break point, and the VS Code debugger never properly connects. So there's something different with what you've got on the ESP than where I got to. But just for reference, with all the only on things with network, I was hoping to demonstrate this RP2040 because it doesn't have networking other than over USB. There's another open PR of mine that is enabling USB networking on every tiny USB port. So any device that's got tiny USB, which is most of them, and it will need, I think, around 20 to 40K of RAM spare to handle the network stack. But then you can have full networking over USB, which means full debugging over USB. So that's kind of where I'm trying to get to with it as well.
Yeah, that would be. Oh, so echo. That would be great. And of course, I was thinking about that, and then I thought, well, let's not get more variation in, because there's also a PR in order to get more detailed line numbers, right? So if now you have two statements on one line, the debugger only stops, right? So if you have A is equals 1, semicolon, B equals 2, you will never hit the B equals 2, right? While you see Python, that's a separate step. So there's a PR out there that also gets that information in. Then we'll probably need to that right. So, but now it's incremental steps, right? I think, right. I saw the other side and then think, well, now there's pieces that I'd like to add, right? So, good stuff.
Love what you've done with it. It's great to see, and yeah, I've felt bad because I haven't had much time to really put into keep it moving. So it's good to see. And you know, I reckon even there's going to be a lot of moving pieces here that will. I do think long term we'll get it into MicroPython, but I think there's a fair bit of rough edges to get sorted right. So working out of a separate repo is probably a great place for now. And once it's sort of in a stable enough position, yeah, then we can get a bit more, or the core infrastructure at least upstreamed and ready to roll out.
Yeah, perhaps that's right, because currently I just put in the compiled firmwares, right? We might want to actually submodule in the things, right? But let's figure that one out. Okay.
So I've just created a debug pie channel in Discord. So Joss, if you could perhaps post all of all the information you've presented, the links, whack it in there, and we'll continue to talk there.
Yeah, we'll do.
Really cool feature to see. It's been years that we've wanted to play with debuggers in MicroPython. So yes, so yeah, it's very exciting.
The performance hit, I don't know how far we'll get with resolving that. The sort of the real debug py, if you're the C Python one, it runs basically a full network service in a separate thread, which is handling all the communications back and forth to VSCode, and like it's kind of a full JSON RPC server, and layers upon layers of architecture that's separated from your code, so only a tiny bit's handled in the debug hook. I was expecting to do something similar in the MicroPython one, and then it would only work on things with threads, which would suck. But I didn't even get a chance. Arguably, Claude Web made such a simple thing that is so much smaller, but it's running all of that network handling in the set trace hook, and the set trace hook is something that gets run on every single line of code run. So there is a lot. Some of that we may be able to optimize or have only run on when needed. But yeah, at the moment it's doing socket handling kind of in between every single line you run in MicroPython, which is kind of full on. It's surprising that it works as well as it does, arguably. But yeah, there's a few different avenues to improve it. But on the other hand, maybe this is something you only actually turn on when you've got a tricky problem or on a chip or unit port that's fast enough that you don't really notice it.
Yeah, and you might wonder, right? So why was I copying everything to the ESP32 rather than doing npm run folder? Because that also runs on MicroPython, and that's also when the stack inspection and the frame inspection happens, and it does that for every byte that gets read, and I wasn't patient enough for that.
Yeah.
Cool.
Yeah.
This is awesome work, guys. Thank you for putting in the time and effort. It's great.